Alright, hey there AP Stats guys. We are in the last three chapters. And today we're going to start with section 10.1. I got good news and I got bad news. 10.1 is going to combine chapter 8 and chapter 9 and smash them together, but we're going to change one thing about it. Okay? So, in this section we're going to look at finding or comparing two different proportions, finding the difference between them. We're going to look at sampling distribution, determine conditions are met, construct and interpret confidence interval, calculate test statistic and p-value, and perform significant tests. This is kind of like a culmination of everything we've done so far. It's a good review. So let's talk about what this means. Or should I say what this proportions? Alright, so let's say there's a school where we want to compare two schools and see if one school has more students doing their homework than the other school. Okay? So, at school 1, 70% of their students did their homework last night. So P1 is 70. That's a statistic. Or actually, that's a parameter. At school 2, 50% of their students did their homework last night. So P2 is 50. So the counselor at school 1 wants to see if this is true. And they did a simple random sample of 100 students to get their statistic from school 1. Counselor at school 2 says, I'm going to do it differently. I'm going to take a sample of 200 students and record P2 that did their homework. Their goal is going to be to see whether or not there's significance there. So, our population 1 has a parameter of P1, a statistic of P hat 1, sample size of N1. I'm just trying to show you guys some, it's a rough day. I'm trying to show you guys the abbreviations, the symbols that we're going to use for this. Now, treatment 2, we're going to put P2, P hat 2, and N2. This is going to be important when we check conditions to understand where the symbols are coming from. Remember, no hat means it's a parameter. It's the believed to be population is what you're trying to find. Statistic is your sample. Okay? Alright. So let's go through and do this. You can write this all down if you want, but so this is all the same from before. We need to check the sampling, or let's look at the sampling distribution. Our shapes for both is going to be normal because they both pass large counts. If you don't know what large counts are, go back and watch your 8.1 or 8.2 video, and that will talk more about large counts. But you're doing N1 times P1, and that has to be bigger than 10. N2 times P2, and that has to be bigger than 10. And then you have to go N times 1 minus P, and N times 1 minus P. Okay? So that tells me that, yes, it will be normally distributed. What's going to be your center of this distribution? Well, your center is going to be your null hypothesis, or what you believe to be true. In this case, school 1 was set 0.7, school 2 was 0.5. What's my variability? What's my of the standard deviation? Again, this formula is old hat, right? This formula is old hat. And we have less, and the reason standard deviation works is without replacement is because the 10% rule holds. Again, if you don't know where I'm getting this from, you got to review old stuff. I'm going kind of quickly. I'm sorry. Not sorry. I want to get to the nitty gritty. Let's do some examples like y'all like. So if we know both of those, we know their center, we know the variability, and we know their shape. This is for my OCD kids out there. I'll erase that. What can I say about the difference between them? Well, if they're both normal, then when you subtract them, they're still going to be normal. Okay? This is what the distribution, if you run simulations, would look like. Where's my face? So they ran their sample. This is to simulate. This is a really quick overview. If you feel lost, that's okay. We're gonna hammer this subject. All right. So they ran their simulation and they got their P1 hat was 0.72 and their P2 hat was 0.47. And when you subtract those, they got 0.25. And then they ran their simulation based on the data from before. So that tells me or when I find the difference in proportions, I should say, if I'm doing my calculations. My mean, you just subtract your P1 minus P2 if you're looking to compare your sample to it. This is your formula for standard deviation when you're combining two of these. This is going to come up a lot. Y'all need to know how to use this. We get 0.058. Again, this is an overview. I don't expect you to get this right now. So, when we are talking about the difference in the two proportions from the two schools, and you want to test the difference whether or not you can actually do your calculations with it, you need to do all the same tests we did before. You need to test if it's normal. And for that, you have to do large counts, but not just large counts for one. You have to do 4 things for large counts. You have to do for both P1 and P2, both populations, or both of your parameters, right? The mean is whatever the difference is. Okay? The mean of the distribution is whatever the difference is. Blue, such a pretty color. Now, standard deviation of the difference of two proportions is this formula right here. It's the same formula we saw before. The only difference is we're adding them and taking the square root of them. Okay? Well, we're still taking the square root, but we're adding them before we take the square root. And that's only true if the 10% condition holds true, right? Does it have to be a random sample? Of course it does, guys. Always has to be an SRS. Onward. Let's look at the fish. No, the answer. Too far. Alright, let's look at these fishes. So, your teacher brings in 2 bags of colored goldfish. Bag 1 has 25% red crackers, bag 2 is 35% red crackers. Each bag has more than 1,000 crackers. Using a paper cup, you take a simple random sample of 50 crackers from bag 1 and a separate simple random sample of 40 from bag 2. Let P1 minus P2 be the difference. So, what's the shape of the proportion going to be and why? Well, you're going to have to do your n times 1 minus p and your n times p and your n times p2 and your n times 1 minus p2. So, you do 50 times 0.25. Took a sample of, so think about this. Here's your N1. Here's your P1, right? Here's your P2. And here's your N2, right? So N times P1, N1 times 1 minus P1, N2 times P2, and N2 times 1 minus P2 all are greater than or equal to 10, so I know the shape is going to be normal. Okay? Find the mean. The mean's the easy one. You just subtract. Whoa, too far. Too far. Too far. For the mean, I'm just going to go P1 minus P2. So I'm going to go 0.25 minus 0.35, which is negative 0.10. Cool. Now let's calculate and interpret that them there standard deviation. So, for this one, we're going to do P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. Add them, square root them, and that's your standard deviation. So we just described the distribution. Okay? So if I were to actually put this into words, I would say the difference between bag 1 and bag 2 in sample proportions of red goldfish critters typically varies by the standard deviation, 0.097, from the true difference, which is negative 0.10. All right. All right, I'm not going to do confidence intervals today. I will break up this video or else it'll be 30 minutes long. All right, guys, that's it. I hope you enjoy your life.